So yesterday we talked about the first of the three trig functions we're going to talk about. Today we deal with the other two. So if you remember, get it? So, toa. All right. So make sure we can actually see that there. So toa, sine is opposite over hypotenuse. So if you want to write it like this, it may even work out better for you. Cosine is adjacent over hypotenuse. And then tangent that we did yesterday was opposite over adjacent. Okay? So today, page 264 of your student journal, you're dealing with sine and cosine ratios. So how does it change? It really doesn't change, other than you're dealing with the opposite and the adjacent sides today over the hypotenuse. Okay, so what you have to be able to do is recognize when you are given the information to utilize sine, and when you're given information to utilize cosine. Okay? So what I'd like to do, if you want, on bottom page 264, you actually have your notes there. But before we actually start that, I want to make sure everyone understands what sine and cosine, more so what cosine means. Cosine means the complement of sine. Tell your neighbor what complement means. They make 90 degrees. Okay? So on the top page 265 says the sine of an acute angle is equal to the cosine of its complement. The cosine of an acute angle is equal to the sine of its complement. What that really means, hey guys, if you don't put the phone away, I practice like chucking them out the window and see how far they skip. It's really sweet. Either that or I just take it away. It sounds funner to skip it out the window though. Mr. Snow gets mad when I throw things out the window. All right. Dude, now they're blaming each other. Oh. Divide and conquer, that's what I always say. Okay? Here we go. Hey, if I know that the sine of A, the cosine of A, the cosine of the other angle is just, you have your 90 minus A. That's going to be the cosine of B. Okay? The sine of A is equal to the cosine of the other angle. So, for instance, let's understand what this is saying. So, someone give me a measure between 0 and 90. 32. Okay, so we take the sine of 32. And what we're saying here then, 90 minus 32 is what? 58. So, that's equal to the cosine of 58. All right? I want you guys to calculate the sine of 32 and the cosine of 58. Okay, so you made sure that you guys are there, that your calculators are in the correct mode. Notice sine of 32 and cosine of 58, same value. Okay? Really, that's what you have there. So, how is that helpful? Well, a lot of times you'll be calculating or completing triangles or doing different things within multiple triangles, and it's good to know that if I'm dealing with one angle that's 32 degrees, well, the cosine of the opposite angle, the other acute angle in the triangle is going to be the same. Okay? It's a complement of sine. All right. That's what that's stating there. Okay. So, what I'd like you to do right now, go ahead and take a look at 1. We'll do number 1 together. Number 1 on X practice page 265. Find sine F, sine G, cos F, cos G. Write your answer as a fraction, as a decimal and rounded to 4 places. By the way, if you paid attention right up here, that's going to cut your work in half on the bottom there. Okay? Give number 1 a go there. Which one are you dealing with? So you want to deal with those ratios right there. Oops, sorry. All right. And so if you're dealing with sine, it's opposite over hypotenuse. So your hypotenuse would go on the bottom. If you're dealing with cosine, it would be adjacent over hypotenuse. So the hypotenuse would be on the bottom. Okay, let's try one. Sine F. So I'll deal with just sine F here. That means if I'm tracing the angle F, off that angle F, I am dealing with the opposite over the hypotenuse. That would be my adjacent. Okay, so the sine of F is going to be opposite over hypotenuse, or 12 over 13, which is approximately 0.9231. Yeah. Okay. What other angle is equal to that one? Maddie? Yeah, so if we go to the, so we're at one acute angle, if we go to the other acute angle and take the cosine of it, that should be the same value. Cos G, okay, so if I were to erase the one that I traced there, and now trace G, remember the side I don't trace is the opposite, so this, what was adjacent becomes opposite, and what was opposite becomes adjacent. So I'm now dealing with the cosine of G. It's adjacent over hypotenuse, or 12 over 13. So yeah, they're the same value. So if you can utilize what we just talked about sine and cosine being complements of each other, that'll save you some time there. That means the sine of G is going to be equal to the cosine of F. Okay, sine of G is equal to 5 over 13. And the cosine of F is also equal to 5 over 13. Okay, so if I go G opposite over hypotenuse, that's 5 over 13, and we know that these two are going to be the same. Okay, it's approximately, that should be positive 5 there. Approximately 0.3846. The same value there as well. All right. Questions on those? Remember, it helps if you trace the angle. All right. Numbers 4 through 6. Write the expression in terms of cosine. So find the cosine value that's the same as the sine of 9. All right. Who's got it? Bless you. Nathan, what do you got? Yeah, 9 plus 81 is 90, and so we just take the cosine of that. Whatever makes it add up to 90, you take the cosine of it. Cosine 81. If you're not sure if you did it right, double check into your calculator. See if it works out. Okay. Cos 81. Okay, which means, like on number 5, what adds up to 90? 60. Cosine 60. Sine 30, cos 60. Same values. So since they're complements of each other, yeah, 13. So sine 77 and cos 13 are the same value, or you could say, I mean, that's what they're asking for here, but we also could say, well, sine 13 and cosine 77 are going to be the same value, as long as the two angle measures add up to 90. Very good? Okay, let's try the same thing on the next page. Number 7. 8 and 9er. Come up with the sine values that will be the got on 7, 8, 9. Okay, what adds up to 90 here? 75, so sine 75. What adds up to 90? 7. And what adds up to 90? 45. There we got it. Same values. Cool. All right, find the value of each variable using sine and cosine. Not allowed to use tangent right now. Sine and cosine. Round to the nearest tenth. So, if I'm looking at this, the way we set these up, you need to first look at the angle they give you. Okay, they give you that 16-degree angle. So I'm going to trace that angle. The side that I do not trace is the opposite. The other leg is the adjacent, and the longest is hypotenuse. Okay, so if I'm dealing with x, I have opposite, and I know the hypotenuse. Therefore, I'm using opposite and hypotenuse. Which of my three trig functions? Remember, so, ka, toa. Opposite and hypotenuse. That is sine. So I'm dealing with the sine of my angle is equal to the opposite side over the hypotenuse. The amount of work I'm showing up here is the type of work you should be leaving on your paper. For sure, man. Thank you. All right, 2.5er. Go ahead and figure out cosine. Dealing with the same angle, it's just now you're using adjacent and hypotenuse. Pretty good? The key is when we put them all the three trig functions on one page will be for you to be able to just decipher which ones you actually should be using. Okay, number 12. Give it a go. Make sure you're asking for help. Okay, so number 12. We trace it. Now I will tell you that sometimes, so if I'm being asked to use sine here, okay, well, it's tough if I look at this and I say opposite and hypotenuse, and I can't actually use sine right now. So I'd have to use cosine. There's my adjacent. So I could say the cosine of 47 is equal to the adjacent over the hypotenuse, which is 10 over d. Okay? Which actually then gives me... Oh, can't see it? There we go. Cos 47 is equal to 10 over d, so that is d cos 47 equals 10. So d is equal to 10 over cos 47. Anyone have a value there? 14.7? Okay. All right, D is 14.7. So here's the deal. If I wanted to, hey, pay attention, please. Hey, sometimes it's like rather than using a rounded value, if I wanted to find sine, I could write in that this angle right here is, what is it?
43.
Yeah, all of them have to, these two have to add up to 90, right? So that's 43. So if I wanted to, I could trace that angle. Okay? And that would make this the opposite, and that's still the hypotenuse. But now for sine, I could use the sine of 43 is equal to the opposite, which is 10, over d. Okay, and I could go through the process of going, that's d sine 43 equals 10. And really, only thing that's changed now is rather than cosine, I'm using sine. That's 10 over sine 47, or 43, excuse me. I'm using sine, I'm using a different angle. So I get 10.7. Okay? Now, why would I do that? Because if I what's that? Do I mean? Oh, yes, I mean 14.7. I see what you're saying. Yes. Okay. Now, if you wanted to, you could go, it's up to you which route you go on it. Okay? I've seen some students, like, they fill in the other angle. I don't know why they feel more comfortable doing that, but okay, that's up to you. I personally just use the first one. Okay? Both of them solve for D. How are you going to solve for C, though? Yeah? They want you to use sine and cosine. I mean, technically. Alexis?
Could you just do sine 47 equals C over D?
So sine 47 equals C over D?
Yeah, and then just solve that, and then you get 0.7 D equals C, and then you just plug in D.
Okay. So we could replace D with a value now, right?
Yeah.
We call it 14.7. Okay. So we get 14.7 sine 47 equals C. Good. So C is 10.7. Sorry, Maddie, that's where the 10.7 came from. I was looking at my sheet. Good. All right. Any questions there? Last problem, number 14. Work together. Make sure you draw a good picture. You have a camera attached to a kite filming a damage caused by a brush fire in a closed-off area. The camera is directly above the center of the closed-off area. Okay? So if you have this kite and you have a closed-off area, maybe that's somewhere down here. This is where the fire was. Okay, a person standing 100 feet away from the center of the closed-off area. So, about 100 feet to that point there. Okay, the angle of depression from the camera to the person. So the camera is on the kite, right? If I were to draw in my right angle right here, is this an angle of depression? Tell your neighbor yes, no, why not?
Yes.
And the answer is, how many say yes? How many say no? The answer is no. Why is it no? That is not an angle of depression. Boy. What do you got? Yeah? Okay, maybe another way of explaining that. I think I understand what you're saying. Hey, look back to your notes from yesterday. Angle of depression has to start from where? Has to start from a horizontal line. Angle of depression would be right here. Okay? That is 25 degrees. Which means this length right here, there's my 90. Now this is also 100, right? Same. It's a rectangle that we formed here. Okay? How long is the string? Well, we're looking for this length right here. So that would be x. It's important that we note that because if we're calculating this, and I'm looking, given this angle, okay, note that that would be adjacent and hypotenuse, which is cosine. Cosine of 25 is 100 over x. Please note if you did it the other way, if you said that this was 25, which is incorrect, and you were trying to find x, you would end up using sine, which would be wrong. Okay? Make sure you're using the correct thing. The correct, yeah.
How do you know whether to use cosine or sine?
You're dealing with adjacent and hypotenuse.
Okay.
Remember SOHCAHTOA?
Yeah.
So, ka is the adjacent hypotenuse.
Is it because there's no opposite?
Why am I using adjacent side?
Why are you using cosine? Like,
I'm using cosine because in relation to the angle, they give me an adjacent length, and you're looking for the hypotenuse. And so the ratio that deals with the trig function that deals with the ratio of adjacent hypotenuse is cosine. If they would have given me an amount over here, then I could have used sine. But they didn't, so I can't use the opposite.
so if they give you all sides, you could use both?
Yeah, you could use either, yeah. All right, what's x? 110.3. Okay? Actually, it'd be 110.3. Okay. We'll leave it there. Hey, I'll let you do part B on your own if you'd like. Okay? Any questions?